Thank you, everyone, and thank you, Tim, for the nice introduction. So my name is Bassam Saadany, and I'm the CTO and founder of Si-Ware Systems. So today I'm going to share with you our product. It's basically a lab in your hand. So it is based on MEMS technology, and the focus is on precision agriculture and food testing. So next slide. Is there something that I press here? Yes. Okay. So first, some information about Si-Ware. I don't want to fall down. So actually, Si-Ware is not a new company. So some of you yesterday have been talking to me about Si-Ware. We were founded in 2004. We had 3 lines of businesses. And now those are separate companies, and Si-Ware today is focused on the MEMS sensing technology. So we are a global company. Our headquarters is actually in Menlo Park, California, with R&D in Paris, France, and in Cairo, Egypt. And we are fabless. So we rely on our partners, manufacturing partners everywhere in the world. We have a very good drive for innovation, a lot of patents, and we're privately held and growing since inception. And today I'm going to talk to you also about our business models. So we have actually crossed the chasm from the MEMS semiconductor. We're semiconductor people, but we're providing a complete product, hardware and software, as you will see. So what is material analysis with optics? It is called spectroscopy. So basically, spectrometers are material analyzers. Those have been around for several decades, typically laboratory equipment, as you can see in the photo here. What we did is basically put it on a chip. And this is actually the smallest of its kind in the world. It's a Fourier transform spectrometer, and it's an award-winning technology that we are very proud of. And actually, the Prism Award, they call it the Oscar of photonics. So Marcelino was talking about movies this morning. So this is no celebrities here. Talking about the technology a little bit, basically the technology is putting optics on a chip. So the EE Times called it the IC of optics. You can see here an optical system, conventional, discrete, with mirrors, sometimes motors, beam splitters, waveguides, and so forth. And with Si-Ware technology, we're able to put that on a chip. So basically, you can see this is a scanning electron microscope photo, top view, of an SOI wafer, where basically the line, like the moving mirror, is actually a mirror that is perpendicular to the plane of the screen here. So we use the Bosch process, Stefan mentioned this morning, to do vertical mirrors with optical quality. And what is nice about this technology, really a great advantage, is the monolithic integration of the components. So all the optics and the mechanics are all defined by the same lithography step. So there is no need for alignment, which is a huge cost saver for all those products built with this technology. Of course, it took us 8 years to get it into volume production. A lot of sweats and tears. So this is the packaging, a multi-chip module. This is the core module with the MEMS, the optics, the photodetector, the ASIC, etc. And we built a complete hardware platform. This is the product, a handheld analyzer, mainly focused on ag and food. It is connected to the cloud, and it has a number of accessories for measuring different samples like grains, liquids, and so forth. And this is a video of the product. I think it should play. So, yeah. There is no sound? Okay. So I will... And so this is the product, and spectroscopy is basically, you see on the left here, the spectra of wheat. And this does not mean anything. You need to use AI and machine learning to get information that people can understand, such as the amount of protein and moisture there. For example, the price of wheat is directly proportional to the protein. So you need to build a prediction model. And those models are actually like the apps on your phone. So there are experts who can build those calibration models. So we came up with a strategy like the Apple strategy, but in spectroscopy. So very innovative name, Lab Store. So basically the Lab Store is a place where the developer would upload their model. So for example, someone who's experienced in testing strawberry would upload a strawberry model to the cloud. And a strawberry grower would buy the hardware and download the app. And then that would turn the hardware into a strawberry analyzer. And this is software as a service. And I'm happy to share with you that the Lab Store went live like a few weeks ago. I mean, it has been in use for over a year by different customers. And today it has the largest collection of calibration models. And it is lab grade, so by independent testing. So this is a publication by the University of Wisconsin and Cornell University. And you can see comparison with the laboratory and our new spectra very close. Of course, it is MEMS. So this is a drop test. You can see, actually, the spectra is very repetitive after the drops. And this is actually soil testing in agriculture. So this is a map of New South Wales in Australia. This is done in collaboration with the University of Sydney, Professor Budiman. And you can see the total carbon and the organic carbon tested also in comparison with expensive machinery there. I still have a minute and a half, and in this talk, I was basically talking about ag and food applications. Just the last slide I would like to share with you, because this is in production today, and what I'm working on today is healthcare, actually. So one application that we did with the technology, we did with Henkel, the famous German chemical company. They own a beauty brand called Schwarzkopf. And we did together a salon lab, which is a hair analyzer. So it's a personalized hair care. So basically looking at certain acids and moisture in the hair. And you will get a personalized custom hair product like shampoo or cream with your name on the bottle. So also in our R&D, some healthcare applications for non-invasive blood biochemistry, such as alcohol and glucose. Also in vitro diagnostics in blood, such as malaria testing. And also in our R&D, there are some testing about early detection of certain types of cancer with a tiny drop of blood. This is still in R&D, but this is the coming wave of this technology. Thank you very much, and would be happy and my pleasure to answer questions. I think at lunch, right? We don't have time now. Yeah. All right.